Your team opens twice the pull request it did 2 years ago. Delivery got slower. Both of those are measured. And there's enough evidence now 2 years of it to explain exactly why that isn't a contradiction. 8.1 million pull requests across 4,800 teams. This is happening almost everywhere. Start with Linear, the issue tracker. 2 years ago, fewer than one issue in 1,000 inside Linear was created by AI. Today, it's just under half of everything created. At the current pace, it will soon author more than people and every other integration combined. That's not adoption creeping in at the edges of one workflow. That's a category of work that barely existed for AI 2 years ago, now approaching parity with every human on the team inside one company's own product telemetry. And that adoption curve looks almost identical everywhere you slice it. Company size barely changes the shape of the line. Adoption roughly tripled across the board at nearly the same speed in Linear's own usage data. It shows up downstream too in the work that actually gets opened. Pull requests opened per workspace are up 111% against a 2024 baseline. That's Linear, again not a survey, not an estimate of intent. What actually got written and put in front of another human to look at. A team that used to open a steady weekly batch of pull requests is now opening roughly double that on the same headcount in the same sprint cadence. Nothing about the review stage changed to absorb it. The gains are real and they're bigger than most people assume. Faros AI tracked 22,000 developers across more than 4,000 teams. Not a single snapshot and not a survey asking people how productive they feel. The same people on the same code bases, measured before they crossed into heavy AI use and measured again after. Epics completed per developer rose 66%. That's a real planned unit of finished work, not a commit count, not raw lines of code going from started to done, at 2/3 more per person than before. This isn't one fast-moving startup skewing an average. 4,000 teams is enough to include the slow, cautious ones too, and the number holds across them. Task throughput per developer rose almost 34% in the same before and after data. That's not a number pulled from a press release. That's instrumented telemetry from the same teams and the same code bases before the change and after it. Nobody here is claiming these teams simply got better at their jobs on their own timeline. Hold on to that, because everything from here forward gets uncomfortable. What happened next was downstream. At the one stage nobody was measuring as closely. That stage has a name, and it's about to get one on screen. So here's the part the productivity dashboards don't show you. Picture a queue, a bar filling from the left faster than it drains from the right. Every pull request that opens is water going in. Every one that gets reviewed and merged is water going out. Median code review time went up 441%. Let that sit for a second. 441%. Not code review disappearing. Code review taking more than 5 times as long as it used to for the same kind of change on the same kind of team. And that's the median. Not the worst case, not one horror story team dragging the average up the typical experience for the typical team in this dataset. The average time a task spends in progress from first commit to actually done rose 225%. Same Faros telemetry, same before and after teams. Put those two numbers next to the ones from a minute ago and the picture snaps into focus. Agents didn't remove the bottleneck in software delivery. They didn't even shrink it. They moved it from the stage where code gets written to the stage where a human has to look at it and decide whether it's safe to ship. This isn't reviewers getting slower or lazier as people. It's more water arriving at the same drain at a rate that drain was never sized for. There's a name for this, and it's older than software. It's queuing theory. Speed up one stage and the constraint doesn't disappear, it moves to whatever's slowest now. So, why did review break? Specifically, start with size. LinearB looked at 8.1 million pull requests across more than 4,800 teams in 42 countries. A snapshot of the whole industry, not one company's experience. AI-assisted pull requests run about 2.5 times larger. 408 lines at the 75th percentile against 157 for work nobody used AI to write. A separate measurement, this one from Faros, tracking the same before and after teams, puts the size increase at 51%. Different dataset, different method, same direction, and that agreement across two completely different studies is exactly what makes this hard to argue with. A 400-line change isn't just more to read. It's more decisions bundled into one approval. More places a reviewer has to hold context on. At the same time, in one sitting. Then wait time. Back to LinearB's 8.1 million pull request. Agentic pull request. The ones where an agent, not a person, opened the change, wait 5.25 times longer for a reviewer to even pick them up. That ratio is LinearB's own published figure, not an estimate. And that's not spite, and it isn't laziness. A reviewer facing a larger, less familiar diff will rationally let it sit until there is an uninterrupted block of time to actually give it attention. A bigger diff sitting untouched for 5 times as long before a single person has looked at a single line of it. Then acceptance. Also, LinearB, same dataset. Bot authored code gets accepted 32.7% of the time it's proposed. Human authored code 84.4%. That gap isn't only about the outcome either. Every rejected attempt still cost a reviewer's attention once the review clock started and ran, whether or not the change survived. So reviewers aren't only slower to open these pull requests. Once they finally do, they trust what they find less by a factor of more than 2.5. And here's the failure mode almost nobody puts a name on: decay. This one's Faros, not LinearB. A pull request gets worse the longer it sits. 26% more tasks now go a full week with zero activity, and work getting abandoned and restarted from scratch is up 14%. So the diff that finally reaches a reviewer isn't just bigger than it used to be, it's older. Half of it needs re-explaining, because whoever wrote it has already moved on to 3 other things. Merging it is a riskier bet than it was on the day it was opened. Bigger pull request, less trust, slower pickup, more decay while it waits, even less trust by the time anyone gets to it. The loop closes on itself and it's self-reinforcing. Every pass through it makes the next one worse. Which is exactly the pressure that produces this. Pull requests merging with no review at all, not from a human, not from an agent, are up 31.3%. Faros again. Faros' own read on this isn't that anyone made a deliberate call to skip review. It's simpler and worse. Reviewers physically cannot keep pace with the volume arriving in their queue, so a growing share of it just goes through untouched. CircleCI's 2026 delivery report describes the identical shift using completely different language. The constraint in the pipeline moved from writing code to validating it. 2 separate research teams, 2 different datasets, landing on the same sentence. Which raises the question nobody in either dataset wanted to ask. What is all of this actually costing? Code churn lines of code, rewritten shortly after they were committed, grew roughly tenfold. Production incidents traced back to AI-generated code more than tripled. Both numbers, again, from the same Faros before and after telemetry. Worth being precise, right here, about what those 2 numbers can and can't prove. They are correlations across a large real sample, not a controlled experiment. Nobody isolated AI as the one variable and ran the same team's delivery twice. What the telemetry shows is that heavier AI adoption and this exact pattern of slowdown move together consistently across every dataset in this video. That's strong evidence. It is not the same claim as AI caused this, and this video isn't going to pretend it is. And it isn't only telemetry. New Relic surveyed 200 engineering leaders in 2026 and found that 82% had experienced at least one production failure tied to AI-generated code in just the past 6 months. That's not an edge case you can wave off. That's the majority of the companies asked. And if you're thinking your team is better run than the teams in this data, that's the assumption we should test next. Here's the part that should really bother you. If you've been nodding along, assuming good process protects you from all of this. DORA's 2025 report on AI-assisted development calls AI an amplifier. Its own language, it magnifies whatever's already there in an organization, strong practices and weak ones, both. The comfortable reading of that sentence is, if your engineering discipline is already good, AI mostly makes it better. 2 years of Faros telemetry complicate that reading badly. Organizations with mature DevOps practices teams in the top tier on deploy frequency and change failure rate, the standard maturity measures saw the same review time collapse as everyone else in the dataset, not a smaller version of it. The same one. Being good at this before AI showed up didn't amplify that strength here. It didn't insulate anyone. It didn't protect a single team in the sample. None of this means engineering discipline stopped mattering. It means it stopped being a shield against this one specific failure. A team's existing strengths are still real. They just weren't enough here. Queuing theory says you don't fix a backed up stage by working it harder. You control what enters it. So 4 ways to do that. And hiring more reviewers isn't one of them. Because more reviewers just adds capacity to a stage that was never the actual constraint on quality. 1. Cap PR size. A smaller diff does more to fix everything you just watched than a cleverer prompt ever. Will it shrink size? Which shrinks wait time? Which shrinks the whole decay loop at once? 2. Move the gates earlier. Push formatting, known security patterns, and known vulnerabilities into the development environment itself before a human ever opens the file. Let automation catch what automation is good at and save the person for exactly one question. Does this change actually solve the right problem? 3. Track review coverage, not throughput. Almost every team already tracks pull requests merged per week. Almost none of them track the share of those pull requests that received anything you'd call a meaningful review. 4. Change what you measure as success. Once an agent is writing most of the code in a repository, review lead time and revert rate on the agent-touched pull requests tell you more about the health of your pipeline than a rising PRs merged counter ever will. And notice the shape of the common field response to all of this. Adding reviewers, expanding QA, building faster incident response. All 3 treat the symptoms sitting at the end of the pipeline. None of them touch the queue that's actually backing up. Here are those same 2 lines from the start of this video. Now you know exactly what they mean and why they can both be true at once. Queuing theory again. Speed up one stage and the constraint doesn't disappear. It moves downstream to whichever stage is now the slowest one left. AI flooded a system built around a human pace of writing code with far more output than that system was ever designed to absorb. If you only remember one line from this video, make it this one. A queue problem doesn't get fixed by explaining to the queue that it should move faster. The fix section is worth a rewatch before your next sprint planning. And if you want to follow up how to cap PR size without slowing down the actual work, that's the next video. Subscribe so it shows up. Is your review queue longer than it was a year ago? Comment yes or no below. I want to see the actual split.